This first lesson for today is on refraction of light. Okay, so we've moved from bouncing of light, which is the reflection, to now we're going to see what happens to an incident ray, so a light ray going into something. We're going to see how it actually bends. And so this is the phenomenon that you get when you're looking at somebody underwater or you're looking at an object underwater. And if you remember the Bill Nye video, he was trying to use those little grabbers to catch something underneath the water. And you're not going to be exactly on where the actual object is, simply because as the light changes medium, goes from the air to the water, it changes speed. And so the light bends, and that's what we call refraction. Okay? So for this lesson, I'm going to get you to start in the note that is the one that would be a little introductory activity. Okay, so it's a couple pages in, and you could try this at home if you'd like. I mean, you probably have a sense of how it would look anyway. Even if you don't try it, I'm sure you get the idea. But it's like, what if you took a spoon and set it into a glass of water, or a straw and put it in a glass of water, or put a penny at the bottom of a cup? And if you're looking at that penny from the top down, or you're looking at it from the side, or the straw at the side of your glass, you're going to see that it looks like it's broken, or it looks like it's bent. And it's doing that because the light changes speed as it goes through air versus water. And if it goes through a medium that's thicker, if you will, it sort of slows down the light. Okay, so you could give this a try, and then you can add on to a little sketch just some of the information that we've got right here. Okay, so the first thing you can see is that I have air up top, and then I've got a medium, which is water. So I've just shown a glass there, and picture that that's water there. What does it look like? It looks like the straw is broken. Of course, the straw is not broken, but we're going to figure out why. Can you see that we've got our incident ray? And so you're going to use your ruler. Picture that light ray going straight in. So essentially the light is shining up into your eye, so you're seeing the light come from below to above. And again, you can change the version of this. You're going to get the exact same angle. Okay, you're going to get the exact same phenomenon, whether you're shining the light down from the top down or from the bottom up. We're going to explain it the same way. Okay, so our incident ray goes in. Can you see where the normal is? Dot, 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 straight down. And then you've got a ray coming out this way, right? Same angle. Incident ray in, it's not reflected back down like it was when we did the mirrors. Now we're changing. Now we're doing refracted ray. And yes, the light is going to go through that medium. You can actually see the light coming out because it's in the air, right? Remember, again, when you had a mirror there, well, of course, the light isn't going through the mirror because it's a solid object. But in this case, yes, the light is going through. So you've got an arrowhead on this refracted ray as well as our incident ray. Now, imagine if you're calculating some angles. So you've got to add on to this diagram an angle of refraction and an angle of incidence. Same as our terminology from lesson number 1. The angle of incidence is going to be between the normal and the incident ray. The angle of refraction is going to be between the refracted ray and the normal. So can you see that? And in this case, remember how when our angle of incidence and was reflected because of the ray rules, you had the same angle. Same angle in, same angle bounced back. That was the law of reflection. Here we're doing refraction. So the angle of incidence isn't going to be the same as the angle of refraction. It's going to be different simply because the light actually bends. How much it bends is something we can calculate. We will be able to figure out the type of substance that the light is going through. And so that's a value that we can actually figure out. We can actually look up. Okay, we know what the speed of light is in air, and so we can figure out what the speed of light is in these other objects as well. Okay, so that gives you a sense of what that setup diagram is going to look like. Okay, let's take this information here and go back to where there's a summary note where we're going to go over a couple of the definitions and put it on a diagram that looks very much just like this. Okay, Can you see as well that there's a few little questions here you're going to come back to filling these things in? Okay. So following the note, back to the very first page, right after the title page, I've got a little summary going on here. Okay, so let's talk about these concepts again. So I have a light ray going into from one medium to another. So it's going to change speed. All right. This is going to be, if I've got an angle, or sorry, I've got an arrowhead on this ray right here. This is going to be my incident ray. Can you see how I've got the normal, dot, 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 dot? The angle of incidence is going to be between the incident ray and the normal. So let me just write on here, first of all, normal. So we've got that. Of course, this is going to be the angle of incidence, and you can write that down on the side if you need to remind yourself what that looks like. So this ray is going from air, where the speed of light, c, is equal to 3 times 10 to the 8 meters per second. Remember, the speed of light is very fast. The n is 1.00 in air. What is n? N is what we call the index of refraction. Okay, there's a calculation you can look at below on this note, and we're going to briefly go over the calculation for how you would figure out what n is. It's kind of based on what happens to that light beam if it goes through a different medium. Okay, so a medium again is just something that light goes through. Are you shining light through air? Then air is your medium. If you're shining light through water, water is your medium. Okay, so we can take that beam of light and shine it through different substances. We can calculate what that index of refraction is going to be. How much is the light going to bend in something that's different? So I've got some information down there below. You can see that that light is then going to go through water. Well, the index of water, index of refraction, is n equals 1.33. What does that mean? It means that the light is going to slow down when it reaches water. And that should make sense, right? If it slows down, remember that analogy that was in the Bozeman science video about the marching band kind of catching up as it turns around the corner? You can also see it in the PhET simulation that's down below. I'm going to sneak to that in just a second and show you how that works. But you can change the mediums and you can see how that light bends. So as the light travels from the air into the water, it's going to slow down. And the rule of refraction is that it's going to bend towards the normal as it slows down. Okay, so you know where the normal is. Let me grab a different color here, and I'm going to just show you what that's going to look like as the incident ray bends towards the normal. Okay? I'm going to draw a line. Actually, let me get rid of that one for a second. Let me try that one more time. I'm going to try to go right from the exact corner, okay? And I'm going to make it an angle that is definitely towards the normal more so than the incident ray was, all right? Now, would I be able to use my protractor and figure out the exact angle? Of course we can, right? That's where we're sort of headed in physics. We're not going to get there in grade 10, but yeah, we could actually do some mathematics and actually figure out what that angle is because we know a whole bunch of other information and other known things about it, okay? All right, so what do we label? Well, we label this right there as our angle of refraction. This was the refracted ray because it was the ray that got bent. Okay, and let's just summarize this. You can see I've already got this one filled in. Okay, so you make your own summary note too if you don't have the notes printed off for you. The speed of light depends on the medium it moves through. Refraction is the directional change of light as it goes from one medium to another. The rules of refraction, which you're going to summarize on the other page that we just was on. Light bends towards the normal when the second medium slows the light down. If you were going from another medium to something that's faster, let's say you were shining the light from water into air, or if you were going from acrylic, like plastic, into air, it's going to speed up. So if the light speeds up in the second medium, the light will bend away from the normal. Okay, so that's what you have to remember. Does it bend towards the normal or away from the normal? If it speeds up, it bends away from the normal. If it slows down, it bends towards the normal. Okay, the incident ray and the reflected ray will be separate by 2 mediums. So let me just show you on the PhET simulation here what you can try. Okay, you can try turning the light beam on and then moving it through 2 different mediums. Okay, can you see here that the medium up at the top of this one is water, and then the medium down below is air. So you can flip between those 2 mediums and practice if it is going to speed up or if it's going to slow down. Can you see what else you can see on here? You can also see the N value. In water, the N value is 1.33. You'll see that from our note from before. And in air, the index of refraction is 1. What if I change this, right? So just see this one for a second. If I go from water to air, it speeds up. And can you see here? There's your angle of incidence. This would be your angle of refraction. Could you measure those to see that it's bending away from the normal? You can. You can actually take your protractor here and actually put it onto the diagram and measure the angles. Okay? And if you were to go the other way, let's say I go from air to air, no change, same. If I went from air into water, it's going to slow down, and as it slows down, it's going to bend towards the normal. So you can see those trends there, and you can take your laser beam and you can move it all around, and you can see that this angle of incidence is bigger than the angle of refraction down below. Okay, so give that simulation a try. Because we can't do it in the lab, you can simply have a look there and be able to figure that out. Okay, the next little bit for today then, I'm going to do the bottom of this diagram in a second. You're going to come back and you're going to work away at a few of these questions just to see if you get the idea of refraction. Okay, what we would have been able to do in the lab is to try shining light through a medium and actually calculating what the N value is. Okay, so have a look through this little lab activity, just see if this makes sense. I was going to take an acrylic block, which is a little plastic piece. Okay, acrylic is plastic. And if you change the angle of which you're shining the incident ray into an acrylic block, you could do some measurements. What could you measure? You could simply measure the different angles. And then there's a fancy function on your calculator, which you'll learn when you get to math in grade 11 and grade 12. There's a sign button on your calculator, and there's a relationship between these angles that you could actually try it out and put it into your calculator and see what you get. But because we're shining the light through acrylic for every single incident ray, same way all the time, this lab helps you figure out what is the N value for acrylic. So if you didn't know what the incident of refraction was, then you could the index of refraction, you could actually calculate it in the lab. All right, so that was it. And the students, if you got a chance to do this, you would see that, yeah, every single time you get N equals 1.48. Crazy. Okay, so mathematically it works out. This is the science behind how you would figure out what the N value is. Okay, so I don't want you to worry too much about that because it's, again, something a little bit beyond what we have time for doing. But you could calculate it. The formula for calculating the index of refraction is C over V. Simply C is the speed of light, which you know as 3 times 10 to the 8 meters per second. And the V value is what is the speed in the second medium. Okay, so you can take that little formula, N equals C over V, and solve for any of those unknowns. If you were given 2, could you solve for the other ones? I'm going to leave the bottom of this here. If you're feeling like a challenge and you want to mathematically figure out this concept, which is called Snell's law, and you want to do a few questions, I'll leave the sample questions here. I'll take a screenshot of this page because I know it's not in your other note, and you can see and you can give this a try if you'd like. Okay, so what I'm going to do now is I'm just going to go back to the front note that we had where we did the summary here on refraction. let's just summarize the bottom, talk about this index of refraction, and then we'll leave it at that for learning block number 1. Okay, so the index of refraction, again, is the number that represents how much slower light passes through a medium compared to the speed of light in air. So the index of refraction from air to acrylic was 1.48. That's what we would have calculated in the lab. Remember, for air, it's 1.00. Water was, do you remember what water was? 1.33. So it tells you how much faster or slower air and acrylic are than in water. This means that light moves 48% slower in acrylic than it does in air. Okay? The formula again, and again, there is a way to calculate, and using the sign button on your calculator, if you were given the angle of incidence and the angle of refraction, you could actually figure that out. Okay, I'm going to stop it here for the first learning block, and there are some questions you can work on for refraction.